What's up everyone, and welcome back to the comms channel. Today's video is going to be part 3 and the final video in the aircraft tracking and alerting series. In this video we'll be going over how to set up this Python script I made called SkyWatch. This script is what monitors for specific aircraft or squawk codes you specify and sends an alert via Telegram. So hang around and we'll get into it.
US Air Force on guard, aircraft 4 miles west of Bainbridge Airport.
Okay, I'll be back in 6 seconds.
We're approaching a restricted area. Restricted area is 1 mile west.
Before we begin, I should mention that SkyWatch is still new and in development, so new fixes and features will be added to it. And many of these updates probably won't warrant a whole video for them, so I'll likely just be making a community post on the channel for these updates instead. If you haven't already done so, be sure to subscribe and go and hit that notification bell to all, so you'll get notifications whenever I make these community posts and you won't miss out any updated features to SkyWatch. So here we are at the SkyWatch Github page where I've uploaded SkyWatch and all the files necessary to use it. Now what SkyWatch does, it connects to the Raspberry Pi we just set up if you're following along with the videos we did earlier. And there's a page on there, which I will pull that up now, data/aircraft.json. And this is basically a list of all the aircraft currently up and all the information around it. So all of these airplanes flying around, they're transmitting their hex code. Well, as you can see, a bunch of info, but the info we're interested in is the hex code, the flight ID, and then there's also the speed and direction and altitude, and squawk is one we're also interested in. So all these airplanes are transmitting all of this information for the most part. Sometimes they don't have a squawk code or they're not transmitting it, but they will always have a hex code, and a lot of times they will have a flight ID along with their latitude, longitude, and altitude and speed and all that good stuff. So what SkyWatch does, it connects to the Raspberry Pi, looks at all that information, and what we do, we provide a list of aircraft we're interested in this watchlist.txt file. So what it's doing, it's checking this list every 30 seconds. And in the watchlist.txt, you can either enter in hex codes you're interested in or flight IDs, or if you know the aircraft's N number, if I can find one on here, here's one with the N number. If you know the N number of a particular airplane, you can also throw that in there as well. So what it does, it will check this list every 30 seconds, and if there is a match, it'll alert. So that is the watch list. There's also squawk codes that it'll alert on as well. So squawk codes, if you don't know what those are, most of the time this is going to be like this airplane here, for example, has a squawk code of 3542. This is typically given to the pilot by air traffic control, but if a pilot gets in a certain situation, let's say they have an engine failure and they need to come in for an emergency landing, the pilot can put 7700 to let air traffic control know that they're having an emergency and they need to land immediately. There's also 7600, which means radio failure. So if the radio fails in the airplane, the aircraft has no way of communicating with air traffic control, so they can put in 7600. And then that way, air traffic control knows that this airplane has a radio that isn't working currently, and that's why they're not communicating. Then 7500 is, God forbid, a aircraft hijacking. So, and there's a number of other things I thought would be interesting to alert on. So the script will also check for any squawk codes matching this list here and then alert on them. And it'll send these alerts via Telegram. Now, as far as setting up the script, you will need to set up a Telegram bot and provide the bot's token. You also need to provide a chat ID, and I'll show you how to set all that up here shortly. But let's go ahead and get this code onto the Raspberry Pi. So to do that, from this main SkyWatch page here, you'll see this code button. So we basically just need to copy this here. So we got that copied. Now we need to open up a terminal, and you do that by clicking on the start button and typing in terminal, and then that'll pull this up to where you can open that up. So then type in SSH, then pi, which is the username, then at ADSB exchange dot local, and then this will of course be your password. And if you followed along with the videos, we changed this password, so put in whatever password you set here. Okay, so on the SkyWatch page we went to code and copied that. Then from the Raspberry Pi you need to type in git clone. I must not have it actually. So the first thing, now this is a fresh Raspberry Pi I just set up to, so you'll likely have to do the same. So type in sudo apt install git, then hit enter. Then you can hit yes on that. Okay, so after we've installed that, now we can type in git clone, and this thing we copied from the SkyWatch page, we will paste that in here by right clicking on the terminal. Now we can go and hit enter. Now if you type in the ls command, that'll show you all of the folders in this current directory. You should just see the SkyWatch folder. So now if we go into that folder by typing in cd, which stands for change directory, and then type in SkyWatch and hit enter, that'll take us there. And if we look at that, we have all of the files you can see here are now located on your Raspberry Pi. And I guess one thing I forgot to mention about these .csv files, they're basically a database of planes that have a list of the hex codes and the type of airplane, and also a link with a picture of the airplane if they have one. Okay, so now we have SkyWatch is on the Raspberry Pi now. If we look at the skywatch.py file, we can do that by just typing in nano, then SkyWatch. Now there's a little trick. As you're typing something, you can have it fill in the rest of it so you don't have to type it all in. So just start typing, like in this case SkyWatch, just type in SKY, and then hit tab, and that'll fill out the rest for you. So if we go into there, we have the code for SkyWatch. Now we have to enter in the bot token and the chat ID. So we'll go over that next here. Alright, so to create a Telegram bot, go ahead and open up Telegram on your phone. And in the search here, search for bot father, and it's all one word. And you'll see the bot father here. So if you open him up, you'll see this start button. Just hit start, and he'll give you a list of options you can do. In our case, we want to create a new bot. So as you can see here, it is / or you can actually just click on new bot and it'll start that process. So the first thing we need to do is give it a name, which in this case you can type in SkyWatch and send that. Now we need to choose a username for the bot. Now anyone can use SkyWatch as the name, but for the username this has to be unique. So I'm going to do TC2 _ SkyWatch _ bot. So you could do something similar, just change TC2 to something else if you want, then send that. Okay, so the bot has been created now, and you'll see this API token here. So we'll need to copy this. So yeah, that is copied. It's copied on the phone at least. I'm not sure if that'll transfer over, but we'll see here. So this token, this is where we enter that in here, where it says Telegram bot token in the code there. And looks like that did work. I'm obviously connected to my phone from a computer. If you're on your phone directly, I would say either send this to yourself in an email or find some way to where you can copy and paste this into your Raspberry Pi screen here. So we got the token in there, and after this video I'm going to delete this bot so this token won't be valid anymore. So that's why I'm not bothering redacting it. But the next thing we need to do is figure out the chat ID. So to do that, you'll need to go to this URL here from a web browser. Now, if you look at the URL, you'll see bot, and then I have your bot token here. So replace your bot token here with this token that we got. So we'll paste that in there. If we go to this URL, you'll likely see that. So the next thing we can do is you'll see this message from the bot father that says you'll find it at here. So we can click on that, and that will go to the SkyWatch bot we just created. So you can hit start, and we've just sent a command to the bot, but this bot doesn't really listen for commands. It's just gonna send data from the Raspberry Pi. But after we sent a message, if we refresh this page here, we'll see some new info. So here you will see chat, then ID. So this chat ID, if you copy that, then we can paste that into the Telegram chat ID there. So now we have that ready to go. Now we're editing this file in Nano. Once we're done editing a file in Nano, you'll see this $X, which means Control X. And then it'll ask you if you want to save, just hit Y, and then it'll ask for the file name to write. We can leave that as is. You can just hit enter there. Okay. So the bot is ready to go. Our script is ready to go. So let's take a look at the list of aircraft. Let's look at this plane here that's headed towards me. Here is the hex code for that airplane. Just for testing, let's copy that hex code, and so now we want to add this hex code to the watchlist.txt. So we'll do the nano command and nano watchlist.txt, and we'll paste that hex code in there, and then Control X to exit, and then hit yes to save, and hit enter for the file name. And if you want to look at it, just look at a file, you can type in the cat command. So if we look at that, there's just one line with that hex code. So now if we run SkyWatch, before I do that, just so we can see. So now when we run SkyWatch, it's going to check that watch list and look for any aircraft in the air that match that watch list. So we have that one airplane in there, so we should get an alert when we run this, and here we have it. Now in this case, there is no picture available in this database. I have these CSV files for the picture database. So these databases don't have a picture for it, so that's why you just see that. But as you can see here, it alerted on it. And then to stop running, you just hit Control C to stop running the program. So that was an example using a hex code. So let's take a look at some call signs. Let's find a unique call sign. Here is a British Airways, which is BAW. So let's go back to the watch list to show another example. So nano watchlist.txt. So let's get rid of this current one. So let's say we want to, well, let's start with, actually, let's skip the British Airways ones for now, and let's look at this Delta. So here we have Delta Airlines. 1183. So let's copy that and we'll put that in here. So if we cat the watch list, now we see there's just one line with that Delta Airlines. So let's run SkyWatch. Now SkyWatch is a Python program, so you have to type in Python space and then skywatch.py to start running it. So we should get an alert for that one, and there it is. So that was an example using a hex code and an example using a flight ID. So another thing we can do, let's go back to the British Airways example here. Let's say you wanted to be alerted to any British Airways plane. They typically all start with BAW, and then they'll have a 26E or whatever flight number it is. So if we wanted to alert on any British Airways plane, it would be BAW, then anything after that. So we can do that in the watch list. So let's go ahead and edit that, get rid of this. So British Airways starts with BAW, and then if we put a star, it'll tell it anything starting with BAW. Go ahead and alert on that. So Control X to exit, yes, and then enter. So we currently just have that one British Airways plane flying over at the moment. So it should alert on that. So let's go ahead and Python skywatch.py, and there it is. Now these plane databases, a lot of times if it's military or government, it will have a image for it. So let's see if there's any currently flying, and there isn't at the moment. I'm sure if we went through enough of them we would see one with a picture, but you get the basic idea. Alright, so the other thing this will alert on is squawk codes. So currently there's no airplanes flying with these squawk codes, but for the sake of testing, let's find an airplane with a squawk code, and here's one using 4040. So what I'm going to do for the sake of testing, so you can remove or add any squawk codes from this list here. You just have to be careful. It has to be properly formatted or else it'll break the code. And if you're uncomfortable doing that, I would actually just edit a current one, but I'm comfortable doing it, so I'm going to add one. So if you notice here, these all end in commas except for the last one. So if you're adding one, we would add a comma to this one. And oops. What was he? 4040. And again, just if you are editing this, it's important to keep the formatting. So we're just going to call this test, and that is fine. So we will go ahead and save it. We'll exit and save it, and then enter. So now we should get a squawk code alert for that one. We actually got two alerts because it found the previous one on the watch list. And here you can see the squawk alert, and it'll tell you, well, let's look at it on here actually. Here we'll see the squawk alert, and it'll tell you the squawk code, and it'll tell you what it means. And in this case, I just put test, but if it was an emergency, it would tell you squawk 7700 and then emergency instead of test there. So that is the basics of it. Now, you're likely going to want to have this running non-stop, and there's a few methods to do that. Alright, so I cleared the screen to make things a bit easier to read. So what we've been doing is typing in Python skywatch.py to start the script. And what that'll do, that'll run the script on the terminal, which is fine for testing stuff out and everything. But if we're going to leave this running for weeks or months on end, this won't work out for us. So what we'll need to do is run this in the background. So to run a command in the background on Linux, you just add the and sign to the end of the command there. So let's go ahead and do that. So when you do that, it'll just give you a new prompt, and it'll also give you this PID number, which is a process ID number. And this is what you need to know to stop a script. To stop a script, or a process rather, you'll do the kill command. So kill and then space -15. And then we'll enter in this process ID. Oops, I didn't mean to do it twice. So 20540. So when you type that in, it won't tell you anything immediately, but that killed the process. But if you hit enter again, it'll give you information on what happened, and it terminated this process, which was at this process ID. Now the reason you want to stop the SkyWatch script anytime you need to make a change to the watchlist.txt, like if you need to remove a flight ID or hex code or whatever from here, once you make the changes to that watchlist file, you'll need to restart the SkyWatch script for it to see the changes. So you would basically kill the SkyWatch script, make the changes to watchlist.txt, and then restart SkyWatch, and then of course add that and sign to the end of it there. And you can see here we have a new process ID. So let's say we got out of the terminal. Let's say we started the SkyWatch script and we let it run for a few weeks, and then we decide we need to add a flight ID to the watch list. SSH pi at adsb exchange.local. So we'll log back into the Raspberry Pi. And remember, all of this stuff is in the SkyWatch directory, so you have to change directory to it. And here we can see all those files, which includes the watch list. So let's say we were making a change to the watch list. Just do soda, which is the air-to-air refuelers around here. So we'll save that file. So we made the change to the file, but SkyWatch isn't going to notice that until it restarts. So let's say it's been a couple weeks and we don't know what this number, this process ID, which you don't have to remember, and I'll show you how to find it. You would do the ps aux command, and what this does, this shows you all of the processes running on the system, and you'd basically have to look through these There it is. I missed it. So there it is. You'll see this Python skywatch.py, which is the command we ran and put in the background earlier. So this first number on the left, this is the process ID of this process. So you would basically run that kill command, kill-15, and then you would enter this process ID into it there. And then that would kill the process. But before we do that, this can be kind of cumbersome to look through all of these, and you saw it took me a second to find this. So easier way to do that, if we do the ps aux command and then add the pipe, which is the key above the enter key. When you hit shift and then hit that key, that'll give you the pipe. And we're going to pipe this command into the grep command, which is a searching command. So if we grep or search for SkyWatch, you'll see it gets rid of everything that doesn't have SkyWatch in the line. Now this, since our grep command included the word SkyWatch, that's going to show up as well. But here we can see the Python skywatch.py command, and here we have the process ID. So instead of having to search through all of that, we can just type in PS aux and pipe it into the grep command, which searches for SkyWatch. So now if we kill -15, we can copy and paste that process ID and hit enter. And that will kill that process. So now when we run that PS aux and grep for SkyWatch, we no longer see it. We only see the grep command, which shows up since we included SkyWatch, but we no longer see this Python SkyWatch command. So that has been successfully stopped, and we can go in and edit the watch list file to however we want it. And once we've done that, made our edits, we can start the SkyWatch script again. And of course, add that and sign so it runs in the background. And we can exit and everything, and it'll continue to run. That'll do it for this video going over and setting up SkyWatch, which will be the final video in the aircraft tracking series. Like I mentioned in the beginning of the video, I'll be providing updates to SkyWatch in my YouTube community posts. So be sure to subscribe and hit that notification bell if you haven't already done so you'll never miss an update. Hopefully you found this video informative and useful. If you did, please be sure to give this video a thumbs up and subscribe if you haven't already done so. Thank you all and have a good one.